A clean AC system is a key factor when guaranteeing the durability of your AC repair jobs. Some components can be successfully cleaned of contamination, and other components must be replaced. The end result must be a system free of any contamination that could destroy the replacement compressor, restrict the flow of refrigerant, or inhibit the heat transfer process. After inspection, it was determined this truck suffered a catastrophic compressor failure. The first step in cleaning the system is to remove and discard the old accumulator and orifice tube from the vehicle. There are several methods for properly cleaning a system, whether using a solvent or liquid R134A refrigerant. This video focuses on two methods of flushing with solvent. Remember, when using a cleaning solvent, you should choose one that has been designed for automotive AC systems. Some things to consider when choosing a solvent are ease of use and removal, potential flammability, compatibility with system components, and the boiling point of the solvent. We recommend Dura 2 solvent as it meets all of our requirements. You should never use mineral spirits, denatured alcohol, carburetor cleaner, brake cleaner, liquid nitrogen, gasoline, or non-filtered shop air, or any other solvent not approved by the manufacturer. When using solvents to clean components, you must make sure that none of the dirty oil or cleaning solvent is left in the system. Proper cleaning procedures must be followed to ensure removal of all debris. The most popular AC cleaning tool is the flushing bottle and spray nozzle. If this tool is used incorrectly, dirty oil and solvent can be trapped in the evaporator. The standard flushing bottle is designed to be pressurized with shop air after the bottle is filled with the solvent. The technician would then disperse the solvent into the component via the spray nozzle. As the tank is emptied and the pressure drops, the solvent quits flowing. If the component is not purged with dry shop air for a minimum of 30 minutes, some of the solvent that is mixed with the dirty oil will remain in the component. Even though the system will be evacuated under a vacuum, the solvent and oil mixture will not vaporize. By adding a regulator and an air hose nipple to the flush bottle, we can attach a shop air hose and regulate the air pressure to the bottle. Instead of using the spray nozzle, we'll use one of our component adapters and attach the solvent hose to the adapter. We can now force the solvent through the evaporator at a consistent 40 psi. After all of the solvent has been expelled from the flush bottle, you can adjust the regulator to 80 psi without ever allowing airflow through the evaporator to cease. This is the most effective way of preventing the solvent or dirty oil from pooling in the evaporator. In this scene, a clip-light power flush machine is used to clean this evaporator. With the accumulator and orifice tube removed, install the adapters to the inlet and outlet of the evaporator. The shop air supply is then attached to the power flush tool. Next, connect the inlet and outlet solvent lines to the fitting at the evaporator. Set the machine control valve to flush and open the flow valve slowly. The solvent will begin entering the evaporator opposite its normal flow. This will force all of the debris out of the bottom through the return hose and back into the power flush machine. All of the dirty solvent will flow through a filter and then back into the solvent reservoir tank, ready for another cycle through the evaporator. It is recommended that you flush each component for 15 minutes. The AC lines and hoses are the easiest components to clean in the system, but may contain a lot of debris. You can flush the hose assemblies with a solvent or liquid refrigerant for a few minutes until debris is no longer visible. Again, it is important to purge with air for a few minutes to clean any oil residue that may be remaining in the hose after the use of solvents. If the hose assembly has an integrated muffler, you could only use liquid refrigerants to clean the lines with the aid of adapters and block connectors. The majority of late model R134A condensers cannot be cleaned due to their small tube design. These small passageways get restricted with debris and solvent, or liquid refrigerant would bypass the debris and flow through another passageway. There are also dams that force the refrigerant to flow back and forth multiple times before it leaves the outlet of the condenser. If the system showed no sign of metal debris leaving the compressor, turn the condenser upside down and backflush with a closed-loop liquid refrigerant flushing process. However, liquid refrigerant is a safer product to use for this job. You should never try to clean the compressor, accumulator, receiver dryer, orifice tube, or pressure valves with solvent or liquid refrigerant. These components should always be replaced on a failed system. Controlling the flow of solvent at 40 psi allows the solvent enough time to mix with the contaminated oil and clean the passageways. After the solvent has cleaned the evaporator, a comprehensive purge must take place. A few ounces of mixed oil and solvent will remain inside the evaporator. If it is not removed, it'll destroy the replacement compressor. The only way to get it out is to purge with dry shop air at 80 psi for 30 minutes. Not 15 or 20 minutes, but 30 minutes. You may think that the solvent would simply vaporize due to its low boiling point, but remember, it is mixed with the dirty PAG oil and will not vaporize. After the 30-minute air purge, disconnect the lines and the adapters. Remember, you can be working on other tasks while the purge is taking place. It's time to install the new orifice tube. The customer asked for an adjustable orifice tube instead of the original replacement part. The automatic adjustable orifice tube will provide colder duct air during high heat load conditions. After transferring the original pressure switch and clamp assembly, pour 1/2 of the required refrigerant oil into the new accumulator. The other half was added to the replacement compressor. Remember to always use new O-rings and gaskets to ensure a leak-free repair job. With the system back together, evacuate it for 60 minutes, making sure that there is no air or moisture remaining in the system. Once the system passes the no leak test by maintaining a vacuum for 5 minutes, add the correct charge of refrigerant. Before returning the vehicle to the owner, perform the after repairs temperature stress test to make sure every component is performing to specifications. We performed a comprehensive leak test and a function test on all the controls. The blower motor is delivering a good volume of air and the condenser fans are functioning correctly. After performing these comprehensive tests, the vehicle can be returned to its owner, providing them trouble-free AC system service.